everyone, and welcome to today's webinar with Crank Software and Embedded Artists, Accelerating UI Development. We have a lot of material to cover, so we'll just get right into it. Our presenters today are Jason Clark, VP of Sales and Marketing at Crank Software, and Anders Rosvall, Technical Director and Founder at Embedded Artists. And we will jump right into it, and I'll hand it over to Anders for a brief discussion on Embedded Artists and what they do.
Thank you. Please let me just share my screen here. So, can you see my presentation now?
Yes, looks good, Anders.
Okay, thank you. For those of you who are unfamiliar with Embedded Artists, please let me just give a quick introduction. We provide NXP ARM-based computer on module solution, or COM boards for short. We have a family of pin-compatible boards. We have a very strong industrial focus with at least 10 years longevity of our products. We are a proven partner to NXP, meaning that we have a lot of knowledge of our products and have a proven track record also with our products. We provide high-quality technical support directly from our engineers also. We have a slogan that's the art of embedded systems development made easy. That means that we want to lower the thresholds when working with embedded systems. So that is a big part of everything that we do. Okay. Moving on, we have i.MX developers kits for all our COM boards. They are flexible hardware platforms together with documentation and guides, and this is just a screenshot of our current list of documents and guides, and we have a lot more in preparation also. This is also offered, of course, together with high quality support. And why is that? It is to get you up and running quickly so you can start to prototype and develop your proof of concepts. It is in this webinar we talk specifically about graphical user interfaces, and for that display interface is needed. And there are quite a lot of display interfaces available on the i.MX application processor families. And here's a table. Some of them actually give up to 5 different display interfaces. And 2 to 4 of these interfaces can be active simultaneously. And you can get a little bit more info about this and how they are implemented on our COM boards and so on via this URL. All display interfaces are available on our i.MX developer kits, so you can access them easily. I want to specifically mention that we have a COM display adapter. That's the board in the middle here. It simplifies things even further. It is to reference design for parallel RGB interfaces to displays. It has a backlight driver with adjustable current, for example. It also has an onboard resistive touch panel controller. And of course, capacitive touch panels are also supported via different connectors. We have chosen to add 4 very commonly used interface standards for smaller displays here. So we have implemented all of these connectors, meaning that there is a lot of displays that will directly connect to this COM display adapter. We have a list of 30 displays that we have tested, but the list is much longer actually. Yes, and one other thing that I want to mention is runtime configuration when adding a new display. We have added 2 commands in the U-boot bootloader that allows you to immediately configure a display. These commands are EA-DISP and EA-TOUCH. And now I'm going to just quickly show how it can work, for example. In the U-boot, if you write EA-DISP, you will get a list of available display configuration. In this case, there is a display on LVDS 0, that's a hand-star display. And then we have as the second display configuration is an RGB interface with an Inlux display. And it also, then it says that the current selection, both of these displays are enabled, for example. Now, in case you want to add a new display, in this case we call this Rogan display, and it's an RGB interface. Then you just write these commands, and then of course you have to check in the data sheet for the display of the different specific configurations here. And then if you write the EA-DISP command one more time, you will see here in the red that I marked in red that the third display has been added. Now I can just easily select this display to be the new one that is used for the RGB interface. Then if I write EA-DISP again, it will look like this, and I mark the change and the update here with red. So these are the few commands that are needed to add a new display very quickly. We have similarly, we have the EA touch command also, where you can configure different touch controllers that are connected to different display interfaces. I will not go into the details of everything you can do with these commands, but you can have a look in this document for the details, for example. I also want to just show you, because Crank Software will give a few demonstrations here on actual hardware, and I just want to show you what this hardware is. It's a 7-inch 800 x 480 pixel LCD from URT, and it has a capacitive touch screen. Of course, we have the COM display adapter also. And then we have an i.MX 7 dual developers kit, and that is quite a powerful processor with a dual core Cortex-A7 that runs at 1 GHz. There is also Cortex-M4, but that's not used in this demonstration. We have 1 GB of LPDDR3 RAM and 4 GB of eMMC flash. And also there is a 1 gigabit Ethernet interface on this board. So that was just a quick introduction, and before I hand over, I must say that I'm very impressed with Crank Software. 90% of our customers have an embedded system with a graphical user interface, and that is the face of a product. We have seen Storyboard customers create products that are really stands out and differentiate them from their competitors. So that is why I think this webinar is very interesting. Yes, thank you very much. That was all for me, and now I hand back to Crank Software.
Great, thanks, Anders. Before we move on to Jason at Crank Software, I just want to remind everyone that we are taking questions, both Jason and Anders, on anything from embedded system development on the embedded artist boards to user interface development and Storyboard suite. So now we'll hand it over to Jason Clark to take us away.
Thanks, Anders, and thanks for that overview of embedded artists. It's really good to see how easy it is to change a display and configure things, and the thought that you guys have put into not only the hardware but the software. So I'm going to cover a couple of things. I'm just going to talk quickly about the industry and how product teams are sort of evolving and changing these days. And then I'm going to talk about, mainly around the areas of workflow and what that looks like and how to sort of arrange your workflow to get the best results and fastest time to market. So we'll go through that, and at the end there will be definitely a Q&A. I'll be doing multiple demos through here, so stay tuned, and I'll be going out to show you running on live hardware and other things inside of our tooling options. So the industry today, Storyboard is used across pretty much every industry. We have customers everywhere. And it's because what we are focused on is how do you move from design to engineering. This is our core competency, and this is a problem that's not unique to any one market. So you see in auto, home appliances, kiosks in your stores, thermostats, industrial applications, user interfaces are increasing in how often you see them, where they're showing up, and we're always being approached by customers to help them with their next version of their UI or how they're going to evolve and such. But it's always impressive, the new companies who are showing up who you never thought before would be putting a sort of touch LCD interface on their system. And, because the world's moving so fast and rapidly that now all of a sudden it's an issue. So the first question we always sort of talk about when we start talking to our potential customers or customers is, what their product team looks like and where their graphics are coming from. So there's many different ways this happens, but I just want to highlight them. The first one is and this is usually your larger companies, but not only exclusive to them. They have a UI team inside. They have a VP of user interface or a director of experience or whatever it might be, and they have a graphics team underneath them that is providing content to the engineering team of what it will look like. We have other companies who are outsourcing their user interfaces to a design firm to come up with the best idea, and then they'll bring it back into their system to implement and move forward with. And then we also have some, usually in the smaller companies, it's usually a smaller engineering team. And inside of there, we usually have a graphical-minded engineer, sort of one person in charge of the UI, or maybe two. But in any of these cases, the workflow is very imperative. And what's unique here is the industry is changing. Everybody's probably started to see this in different teams, but the number of designers or user experience people that are sort of very key to a product success and involved in the development team are increasing immensely. Then one big stat I saw recently was that companies like Google, Amazon, and Facebook have increased their graphic design teams by 65% year over year. That's a massive number of graphic talent and user experience talent coming to these teams, and you can only imagine how the same trend, whether at the same level or to some degree, will sort of influence the embedded market too. So when we look at these product teams today, the downfall of what's happening is design and engineering are separated. So when a product is being evolved, somebody creates a look, a feel, a design, a user experience, whatever you want to tag it as. Maybe a prototype's built, but at some point that's handed off to hardware, to the engineering team. The engineering team tries to implement as best they can on what they were given, interpreting the subtleties of what they did, but not always getting them right. Sooner or later, it may go away for a couple weeks, maybe a month while engineering tries to do this, but then it comes back to design, and design says, that's not right, this is wrong, this has to change. They go back, they implement again, and maybe by that time they started to get user feedback on the product. For one reason or another, the hardware had to change, the touchscreens had to change, maybe a resolution difference. User feedback's implemented, and there's a whole new skin on the system. It could just be senior management didn't like the look, and they needed a new look. At that point, it then puts engineering back where maybe have to step back even further than ever thought, because the UI was written so tight and so tightly coupled that it's hard to redo and iterate through design change. These are the back and forth that really affect a team as they're trying to get to market. And these kind of things end up causing companies to release with a less than optimal solution, because sooner or later what happens is these iterations and changes and feedback loops are so disruptive and take too much time that somebody needs to, at some point, make a call and say, no, we're shipping it with this, it doesn't matter. And, we've talked to so many teams over the time where we go into their product teams, and they are not content with what they put out to market. They're saying, oh, we wish we got this change in, but we couldn't do it. We wish we had done this, we didn't have time to make these changes. And this is the issue that people are facing. So as most people know, what you really want to get to is more of a parallel workflow. And, it's not a secret here, what I'm telling you. It's pretty obvious. But what we want to do is definitely separate the areas of concern, the user interface design and the development, and allow each to iterate at their own pace. And, once you diverge these two streams, the UI team can make changes, they can iterate, they can quickly test out new design ideas and see how they feel, collect user feedback, and move along at a pace that doesn't affect the underlying system team who's trying to do their development, their own testing, and stabilize the platform, and make sure that all the functionality is exactly how it should be. So this is where we're focusing on today, is how do we make this happen? Everybody knows that this is the way to do it, but few people really achieve it. So the engineering workflow is where I'll start, just because Storyboard is more about the user interface end of it, as you can guess from our company. But if we don't enable the engineering team in any way, then we're never going to get there. So what does this mean? So just taking a step back for a second and looking at the engineering team's concerns, this engineering team is more focused on, the system engineering team is more focused on the system's performance, how the code looks, how they're getting to release, maybe their standards they have to do, how do they scale with future releases, the functionality, the board support package. This doesn't mean that they're not opinionated on the user interface or they don't care about the user interface. It's just not what their job is entailed, and it's not what they're focused on. Lots of people are opinionated on a user interface, but only a couple are actually really responsible for it. So to get to what you see up above, this separation of design and development, the first thing we need to do is separate the front-end UI logic from the back-end UI logic. And to do that, it's nothing new. People have been talking about model view controller architecture, separation of concerns, or whichever title you want to put on it, but you need to separate the front-end logic from the back-end logic. What happens with so many teams is they start off with a product that doesn't enforce this architecture. And due to, time to get to an early prototype, time to show something quick, management pressure, they end up ignoring creating a nice, clean architecture right from the start. So this causes issues because the pressure is never relieved, so nobody ever has time to go back and say, no, that clean architecture we should have implemented, we should do it again. And so many times we walk into customer sites where, they're having problems iterating with their design, they're having problems putting a new update of the UI, and it's because the code is so tightly coupled. And, every one of these teams always says, oh no, our intentions were to completely decouple the UI from the back end. It's not the way it turned out. Storyboard has a lot of ways to do this. Our actions and events inside of our system, we have C libraries to enable this message passing. Our Lewis scripting also enables it too. But one of the key components here is, as an architecture, Storyboard is a runtime engine model. And so what this means is you can't write code inside of us. We are completely event-driven. And what that means to you is that we enforce this UI architecture that everybody knows is the best practice. Well, with Storyboard, you have to do it this way. And it is not a slower way. You'll see even when I do these demos, the speed at which we can show something real and visualize it and talk about the UI is not, it's faster than pretty much anybody out there. So we're very confident in that. So creating a clean architecture that supports this is the first step, because once you've created this architecture where you can send encapsulate all your messages and the data that moves back and forth between the back end and the front end. At this point, the two teams are able to move separately at their own pace. Hardware is also an important part of this, and so I mentioned here embedded artists, as they have their COM modules, they are able to, maybe as the UI evolves, changes have to be made to the LCD. Well, as you saw from Anders' presentation, you can easily change the display, the touch controller, and you can also remove their COM modules and actually upgrade or downgrade the CPU you're using based on, how your user interface ends up being. Some customers start off and they're not sure how much resources or how much CPU, or do they require a GPU at the same time to accelerate their UI? And solutions like these give you the ability to make these decisions a little bit further down the road when you have a much better idea. So right now I'm just going to give you a quick demo of what I'm talking about here and give you a first look at Storyboard and us running on the hardware. So let me just move this aside. So here's Storyboard. Also what I have here is a video camera. It's a little dark in here so that we can get the view right and you're not just looking at a mirror reflection of myself. What you're seeing here is the Embedded Artist i.MX 7 board running. I'm only showing you the display right now, but the rest of it's there, trust me. What you're looking at running on the screen is the demo images from Crank software that are pre-configured and able to run out of the box. We give the SD cards able to be downloaded off our system, plugged in here, and you'll get multiple demos of different home automation, medical, washing machines. And they change depending on the processor and stuff you're using. Because it's an i.MX 7, these are all 2D demos, but if you were using the Solo X, there'd be more 3D enhancements and involvement there. You also notice there's the IP address down at the bottom, and this is so we can connect. So this system is set up with SSH and SCP, so I can, look at the system immediately and see how it's running. So I'm just going to set this aside for a second and come back here to Storyboard. And what I'm going to show you guys is a sample that we have right out of the box. So if you went to our website, there's a 30-day eval, downloaded Storyboard. You can easily say import a sample project. And inside of here, we have one called thermostat.io. It's a very simple sample. It's pretty much been with Storyboard since day one. And it's just a simple-looking wood background thermostat. What's nice about this demo is if you're looking at how do we connect and how do we compartmentalize these different modules inside of here, we do give you the source code. So Storyboard, as I mentioned, we are a runtime model. So when you're developing in Storyboard, what we export from our tooling is a model. It is not C code. So this does really prevent the urge for somebody just to type all their code right into the UI. They do anything really you want to do with C code, you're going to send an event off to another task or process in the system. Inside of here, we do have all the source code for how you would connect with this. You can see here the events and how they send back. Here's the structures that are moving back and forth, and they'll show you how to send these events and send them back and forth. Sorry. It is not where I want to focus at is writing code today, but you can take a look at this if you download it yourself. This demo, once you've looked at it, you can run it on your system, you can play with it, see all the animations run, go back and forth. What I'm going to do is take this and put this on the embedded hardware. So I'm going to say export this to my embedded target, and let me see. So that happened immediately, and let me just bring it back a second here for you guys, and so I can unwind what happened there. It's because I forgot I had the target configuration already set up. I was going to walk you through that. So if I come back here and I look at what happened inside of there, this is the export configuration. We said I'm going to export the thermostat.io sample. We're going to send it to a Storyboard engine. We're going to do it over an SCP transfer. And that address you saw at the top is all I need, the password, and then I gave it a directory. And then after the transfer, we are able to execute a script over SSH, and so I have a launch script. If I come back to here and I look to see what that launch script looks like, these are pre-configured on the boards. If you had a board that we didn't pre-configure with our demo images, you'd have to copy these files over, but that's about it. Inside of here, we would see launch script here, and there's no return at the end, but you can see here, all that happens is we set up a couple of environment variables, then we run our storyboard engine, pass it the touchscreen information, and then the file that was running it to. So that's all there is to it, and then it runs. I sort of messed up my terminal there. Let me do that again just in case. Oops, in case you missed that. And that's all that's really required here to run the system. So what happened when I downloaded that piece, and I can do it again, just here I'll move to a different screen so it looks different, but if I export this guy again from, I got a window open here, he just does simply a transfer over to the system, and then it's running here on the background. So I can now change the screens and see everything. In this scenario, if I wanted to send an event here, there is events already set up, so I can come into here, and from here I would go to runtimes, the Linux one, and the binary, and then from here I can simply send an event. So, sorry, let me just grab this so you don't have to watch me type. And IOGen is an event piece that we have inside of our system that helps people. So they're just some helper utilities, so you can generate an IO message or receive an IO message for testing purposes. You know, in your end product, you'd have this all encapsulating code, but you can see just from the command line, I can generate the event and drive the UI. And so this is what we do inherently from Storyboard, is make it so that you have an immediate separation of your user interface from your design, from your back-end logic. So bringing this back to our presentation here. Sorry. Now I'm going to just jump into the designer workflow. There is still other parts that we do help with system resources, caching, everything else that the system engineering team would care about. I just wanted to sort of break out how does this separation of workflows happen, and the first part is creating an event message passing system to do that. So as we get into the design team, you know, it's obvious their concerns are different. You know, everybody has what they're worried about. And the design team is worried about the presentation, the usability, how the animations look, the user's experience as a whole. You know, collecting feedback and quickly testing out these ideas, because, you know, it's not going to be long before somebody starts using the interface in its true context. You know, up until this point, it's all been sort of whiteboard work and prototypes on whether it be a tablet or a desktop, and not inside of the true interface that it would be used at. And so there is always some iteration that can happen at that point. So how Storyboard helps designers work through this is we start by importing the assets that they have and making it easy to bring them in and start working with them. So we bring in Photoshop files, FBX for 3D models, TrueType fonts, different images, formats, everything, and they can bring it all in and start controlling it. So the most powerful part of this we have is our Photoshop import. And what's so great about there is a Photoshop file has all the information we need to take all the naming, the hierarchy, the positions, the fonts, the visibility settings of a look and feel of something, and then immediately start working with it. This is a giant time saver. So when we come back to, our system, I'll show you a quick import of a Photoshop file. The next piece of that equation, and there are a lot of things in here, and I'm only picking a couple to show to you guys, is the animation timeline. You know, sure, the designers can come in and see the layout and everything and look at that, but, you know, sooner or later, how things move, how things look, and how they feel is very important. So we need to give an animation timeline that feels familiar, aligns with things like, you know, After Effects and such, so the team can actually go through and try out new ideas, change the rate at which animations move, or slide them around, change the timing, and fully control it. And this is an area where, you know, we see the biggest gain when we do demonstrations for people and such. Our UI team internally here can create amazing animations. And the subtlety and the detail that they put into it really even makes our low-end platforms look so much richer and stronger. So I'll give you a quick demo of what this means and how this looks right now. So I'm going to come back to Storyboard here. And here I'm going to show you a Photoshop file. So this is a Photoshop file my designer's made for me. It's got a couple of different screens. It's pretty simplistic, but I don't want to get too detailed here. But inside of here, also on this home screen, there's a start button, and he's covering up a bunch of other buttons that you can see inside of here. So what we're going to do is we are going to import this Photoshop file, create multiple screens, and then also create an animation and go through it so we get to start to see how fast we can get a feel for what our design looks like. So the first thing I'm going to do here is I'll just close my thermostat demo, and I'm going to say I'm going to do a Photoshop import. My Photoshop import will be of my new washing machine here. I'm going to create a new project. We won't get into all the other pieces inside of here. But if I say finish, immediately what you saw inside of Photoshop is now visible here. All the naming that you saw inside of there is all available. Anything that was visible is on screen. Anything that was turned off with their visibility is in an unused layer that we can leverage for other screens. So, as I showed you there was a start button with some buttons behind there. They are all here ready to be used. The system is completely carved out, so you can see if I select something or if I switch to our wireframe mode, you can start to see how everything is put together there. First thing I'll do is I'll create a new screen just to show you what that looks like. So I'll say Add New Screen, and here I will take the temperature screen, so where you select the temperature of water you want. I'll click this layer, and I want to grab the background layer, and we'll call it Temp Screen. And we click OK. So now I have my second screen in my system. To get to that screen, I need to give a way to get there. I'm not going to click the Start button to get there. I'm going to click this Wash button to get there. So when somebody clicks on this button that's behind my Start button, I can simply say I'd like to add an action. And my action is if somebody presses on this button, that we do a screen fade to the temperature screen. It's going to go at 500 milliseconds, 30 frames a second at a linear rate. Any of these can be changed. I can make it move faster. I can up the FPS depending on my system. For what we're doing here, these are good numbers, so I'll run with them. And I've added that piece. The only thing I'd want now is to be able to go back. If somebody hit back, I want to go back to the main screen. So I'll say if somebody touches the back button, if they press here, we'll do a screen fade, and we're going to go back to the washing machine screen. So right away, if I just simulate this in my desktop, this is ready to go. So I've brought in Photoshop, I click on this button, I move to my next screen, I hit the back button, and I move back. So the next thing I want to do is let's create that animation that I had at the very beginning. So what I want to do is have the Start button slide off the screen, and there's 4 options as far as the different directions we can go at the start, and I'm going to have them expand out. So here I'm just simply going to click up in our top menu bar, there's a record screen, and this makes the easiest way to create animation timelines in Storyboard. So here, anything I move will be recorded and put onto an animation timeline. So the first thing I'm going to do is I'm going to want to get rid of this Start button. So I'm just going to move him to a Y of 480. The screen is 800 by 480, so 480. Y is off the screen, so you see him down here below. At this point, I can hit a keyframe, so this will actually keep my animation timeline a little nicer and break it into keyframes. This is how I want to look at them. And the next thing I'm going to want to do here is start sliding these buttons out. So this Wash one is going to come out here, the Smart over here, and there's alignment pieces. I'll fix them up a little bit better, but right now I'm just going to give you the idea. So, and we slide this guy over here, and now, my designers would be much more picky about how this all looks. I'll clean it up a little bit. Oops, I'll grab them all, slide them out, and then if I come up here, I can say evenly distribute them, so that way they're nice and move tightly. And now I can say stop this animation. I'm going to call it my start animation. I'm going to say move this at 30 frames a second. If I was on a GPU with a a 3D GPU, I'd probably say 60 frames a second, but seeing this is only software optimized this platform, I'll go with 30. And right after it puts everything back on my screen as it was, and it's built me up an animation timeline. And when I was moving those things around, I didn't notice I moved the Y value also, which it wasn't really my intention, so let's just get rid of that. I didn't really want it to slide up at the same time. So I'll remove the Y animations. I only really want the X's to move on all those things. So what's happened here is I have an animation timeline. By default, it puts everything at 500 milliseconds for a step. The first step is the start button moves in the Y direction, and the 4 buttons slide out to their new X position. I can see it inside of my animation preview, so if I wanted to walk through what this looks like, I can see how it goes immediately and test out all my ideas. Inside of here, I can make changes I want. Anything I want to drag, so if I wanted them to come out at a bit of a jagged pace, maybe I didn't want the start button to move away so fast. All these things can be done. If I wanted to change the rate, right now everything's moving at a linear rate. Maybe I want to move them at a different rate, such as an ease in, an ease out, whatever it might be. Or if I want to create my own custom animation rate, whatever it looks like, I can do that too. And I can just save that, and now this guy moves at a custom rate. And once again, I can still preview that here and see how those changes make a difference to what I did. So now, didn't do much, but you can sort of see how they move at different paces. They don't come all at the same spot at the same time. Not the greatest animation. I'm not the guy who would tune these things and make them work the way they should, but you can get the idea of what's happening inside of here. So what we've done so far, the last thing I need to do here is on the start button is tie the animation. So when somebody hits the start button, it does something. So we'll add an action here, and if somebody presses on this start button, I'm going to do an animation, and my animation is start. So if we simulate this here, save it yes, we can see immediately that things come out and moves at a weird rate because I did that. But I can click on the washing machine, it fades to the next screen, I hit back, it comes back. So I can see how it looks and feels on my desktop. I can validate what I wanted to happen happens. But the next part is, well, I want to see that on my machine now because, performance may not be the same. The colors may not look the same on the LCD screen. The touch system may be a little finicky. So let's validate that. So inside of here, let me do this the proper way this time because we did this earlier this morning, so I had these already done. But once again, it's going to do the exact same thing it did before. So let's close this. And I will hit transfer over of my new washing machine look and feel. And immediately it'll go over. And my system's up and running here. And you can see it running live on the board. If I hit the start button, everything comes out. Now I'm sure it looks a little choppy through a WebEx because it's not, going to drop some frames, but feel free to download our demo images and our eval and try it out yourself. I hit the wash button, I move to my screen. I hit my back button, I move back. This really increases the ability for somebody to look and understand. So not only now can a designer or an engineer work inside of Storyboard at this level. You may not have designers, but doesn't mean their engineers won't work here. But a designer could also do what we just did. They could import the Photoshop file. They can try it out on a system and see how it runs. So many times you have a design that somebody's written, and they prototyped it on a desktop running some Pentium class CPU, and they don't realize the constraints of the real embedded hardware. So this allows the designer to understand what is that animation going to look like when it runs on the system? What are the colors I selected going to look like when they're in that LCD? And this allows them to iterate and do things a lot faster. And they don't need to involve the engineering team. We worked with many customers even before we created Storyboard where they were using products where when a designer just wanted to see a font change, a color change in an icon, they had to get somebody from the engineering team to do their changes. They would go create it, do a full build, flash a system, bring the system back for the designer to look at. The designer might go, no, not quite it. I want it a little bit more over here, change it again. And it's this long cycle that just crushes productivity. So let's go back to our slide deck here. And we'll put this down. Now we're back in PowerPoint. So that's great. I have my engineering team decoupled. They are sending their events in back and forth. My design team can bring in their Photoshop files. They can create animations. They can move stuff around. They can change fonts. They can control all the bits they care about. The problem where so many of these solutions fall down is nobody actually looks at, well, what else has to happen? And unless you bring those two workflows together, you're really never going to gain the advantages that you have there. And by that I mean a lot of tools say, oh, well, a designer could come in here and move an image. They could come in and change a font if they want, but they can't really do anything productive. And the worst part is they can't commit it to the source code repository, whatever you're managing all your source in. So they could fiddle with things, but they can only do a couple of things. And if they can't do everything they need to do inside their jobs, chances are they just won't do it, and they'll push it all back to the engineering team, and you're right back where you started. So what Storyboard has done is we looked at these things, not only bring these workflows together, but how does iteration work? So I'm going to give you a quick example in a second of what happens when this design changes, and what does that look like to the end user. So, you start off with one design, and it's not going to be long before somebody says this design needs to change. The UI is a very contentious part of any product. Everybody has an opinion on it. There's user feedback, there's senior management, there's other developers. Everybody, believes they know usability and what's the best way to do it. And not to say that you should throw this. Some of these ideas are great, and you need to implement them. And the worst part is if you have great ideas, but implementing them is too hard, that is just a waste. Great ideas should be, and if you don't have a system that makes it easy to revisit and sort of work through these ideas and try them out, you're really putting yourself in a bad spot. There was a report that came out that said, the effort that you put in on usability and user interfaces, there is between a 10 and 100 times return on investment. They're just saying that's how critical it is to product acceptance, product growth in the market. To think about those kind of return on investments, but because of your infrastructure you can't leverage it is, it's not a good thought to have. So we'll walk through an iterative design idea and also team collaboration. As I said, all these different groups, there's multiple files, multiple locations, and they're all developing one product. How do they bring that together? There's multiple solutions in here, but the one I'm going to show you today is we do have a graphical compare and merge. So you can easily compare a model against what's checked in a source code repository or compare two models. I'll probably just compare two models that are identical today. I'll give you an example because I don't have my current one checked in. So this will give you an idea of what that looks like, but we don't give you a text comparison because any designer won't know, a for loop change, what does that mean to the UI? They need to understand it at a level that makes sense. So we give you the tree structured view that your whole hierarchy's in to compare and see the differences. But not only that, we'll give you a graphical compare of what that transition and what those changes look like and what do they mean to the UI. A lot of times people don't realize they changed one button, but that button's being used in 10 different screens, and they don't understand that that change that they did affected other things and understand how it comes together. So let me walk through a quick little demo of that. So we're going to start working just exactly with what we had right now with our washing machine. Sorry. And I'm going to come back to Photoshop. So what's happened here is my designer, he came down and he said, no, the colors don't work for us, and the buttons back there, no longer are they square, they're round, and we're changing a bunch of colors throughout the entire system. And not only will colors change, but there are slight changes in positional data that we want you to implement too. So if I took that PSD and come back to our Storyboard designer, and I say Photoshop re-import, at this point, all the stuff and work we've done inside of our system will not be affected. It may need to be changed because the design's changed or updated. Our animations may not work. In this case, they will. But we can come in and say, I'd like to re-import a Photoshop file and compare it against this current model. What's brought in is a master, and it goes through and looks at each icon, each image, and says, here's the one you're just about to have, here's what you used to have, do you want to replace it? And I can slowly pick one at a time and say, yep, replace those. And It will be happening live back here. You probably won't see anything until I hit something that affects back there, but, here's the start button, so you see the start button changes. I'm confident in my designer, so I can just say, yeah, bring in everything, and, we'll just match it all. And you can see immediately my UI in the back changes. The next step I can come look at is not only did the images have to be replaced, but the size and the position of the controls that they were in also got updated. So, you can see here, if I click the start button, it starts moving in the background here. So I could say, yeah, I'll take all the new updates on changes on that. If I click next, if there was new content the designer had given me inside of this Photoshop, it would appear here. So I could say, yeah, I want to bring in these new objects. So what's nice here is I can bring in everything like you just saw me do, or I could bring in a couple of pieces and cherry pick the solutions. So at that point, I can say finish. It asks me, do I want to keep my old images or overwrite them? Well, I'm very confident this is the way we're going with our design team. So I'll say overwrite them. Plus my source code repository can get them all back for me if need be. So I say yes. And immediately my new washing machine is run here. So I can say simulate. I can see it, everything works as I anticipate. The screens transition as I want. I hit the back button, it comes back. If I want to see it on what does that look like on my target? I have my old one there. Well, let's see it. So now here I push my new one to my i.MX 7 target, and I can look and see how these look and feel for me. You guys may be getting too much of a reflection here because it's a darker theme, but the point is now you can see it and make intelligent decisions on what you should do next with this information. Whether it's best to keep it the way it is or you should, iterate more. These are all the decisions you need to make. So it's very powerful. The iteration process is so important to UI, as I mentioned, because it is consistently a spot where it just crushes other companies and solutions because they just can't move and they get stuck, and iteration's hard. And as I said, they end up going to market with less than optimal solutions. So what I've been showing you here is our Storyboard suite. There is a 30-day eval available on our website. How we find Storyboard different is that we believe, we're the only people who have looked at how can designers and engineers work together equally with the functionality and workflow that they require. And not only looking at it for just enable them in key moments of design, but support them so that they could work on a project from end to end and be involved. We also took a very long look, hard look at how do we make it so that change is not so crushing and so time-killing. So we put a lot of hooks to make sure that we can embrace change and make it very easy to iterate our development. And once again, we are built exclusively for the embedded system. So everything you see here, it can run across multiple platforms. We run on MCUs all the way up to MPUs, 2D platforms, custom 2D optimizations, 3D GPUs. We can give you a single solution so your team can come up with concepts, ideas, and not have to worry about the end hardware of where you're going. We can support it, and your team can easily move there. Also, just one more mention, we do have design services in-house if customers are looking for something along that line or help with updating their UI on their product, or they have an ideas and they don't have somebody else to help them with that. Because we've committed so much to this design process, we do have designers on staff who are creating our stuff and also helping our customers. So just like to point out, along with supporting new platforms, other standard stuff you'd expect from us, we do have this definite knowledge and expertise inside our house. So thank you very much. I'll pass it back here to Roy.
Great, thanks, Jason, and thanks for an excellent presentation. We do have several questions queued up, so we'll get through as many of them as possible before the end of the webinar. If you do have a question or comment, please enter them in the Q&A tool, and we'll just go right from the order that they came in. And Anders, you're free to speak as well. So the first question is, my Storyboard app, so this is, I guess, an existing user, my Storyboard app is not as quick and responsive as I'd hoped. Are there ways of pinpointing performance issues?
Yeah, there definitely is ways to pinpoint performance. The easiest, and we can follow up separately, always feel free to email support, is we do have a performance log built into our tooling solution. So it will show you how long every image took to load off the file system, render, draw, and where those, what's killing you. You know, you can see every layer draw, every control draw, every screen, and how much the combined time builds up. And usually there is something sort of, depending whether it's 2D or 3D, that's causing that issue. You know, a lot of times with 2D, there's some giant alpha blended apps images covering the entire screen. So every time we update a small dirty rectangle, we have to update a larger amount of the screen, and we can do a lot more redraws than anticipated. So if you look up our performance log stuff, you can see information. You know, another nice thing just about to point out to solutions like Embedded Artists is, you know, if ever you needed to, you know, sometimes it is just the CPU can't keep up with your anticipation. You know, you have to make sure that you fit the world that you're expecting, and I'm not saying you're not, but the nice thing with these solutions is if you ever did need to upgrade, the upgrade solution is very clear and easy to do.
Excellent, thanks. The next question is, and this is a common question, I'd like to provide a storyboard app to my client. Is there a way for them to evaluate that application without having to install your product?
Yeah, so if somebody created an app, or just take any of the apps we showed here today, there's multiple ways we can share them. We do have a design report where we will export a PDF or an HTML version of the app, but if they wanted to actually interact with it, the easiest ways would be we have an APK export where they can export an Android app. They could send it right to the person to install on their phone or tablet. We also have iOS apps that we can export, but we also have a standalone Windows executable app that you can send to somebody, and they can just click on it and run it as is.
Okay, great. This question I think is for you, Anders. The question is, do you support multi-touch or on-capacitive touch panels? And secondly, what type of multi-touch operations do you support?
So, it's actually not something that is supported by the hardware, it's software issues. So it basically comes down to, how is the Linux driver implemented, for example. And the capacitive touch panel controllers that we have implemented with the EA touch command, for example, they all support multi-touch.
Yeah, and then bringing that back to Storyboard, we do have built-in multi-touch support, but it does also, there's a whole chain of people that are involved here. Well, not a big chain. There's the hardware. This is hardware screen support multi-touch. Which OS are you using, and what input API are you using, and then we sit on top of that. So on Linux, there's multiple APIs, but if you use the mtdev API, we immediately pull in the multi-touch commands. If you're on QNX, Windows, different platforms, they all have different ability to support these multi-touch pieces. And then there's also with Storyboard the ability to just go directly to hardware and control the touch controller.
Okay, great, thanks. The next question is, can you explain a little bit how the integration between the target OS and Storyboard engine looks like? Is it one or multiple processes or tasks? Is it an event-driven structure?
Yeah, so it is a single process on a Linux application. So the things change depending on the OS and the CPU architecture. By that I mean on an MCU platform where you don't have a memory-protected system, and we're running something like FreeRTOS or Micrium or ThreadX, and there we are just a couple of processes sitting side by side by your other, well, it's a couple of tasks sitting side by side by your task. On a Linux system, as you saw when I ran these, it was just a process that would run Storyboard engine that would load the model, display everything, drive the interactions, and open up the communication channels for the I/O to go between. Is there another part to that question?
No, that was it.
Okay.
Yeah. Next question is related to performance issues. So are there tools to test events and data payloads to and from your Storyboard application?
Yeah, as you saw what I used inside of there, we do have a piece called IOGen, but you are able to capture your events at different layers and validate that the expected results are coming in. You can catch them in Lua script. We can validate them inside the C code. So there is multiple ways to do that. We do go very open because we like to make it as open as we can for our companies using us, but we can show them how to tighten the results and validate them. So.
All right. Next question is, how much work is it to change the display resolution of an existing design?
So this is probably going to be a two-part question, and I think Anders kind of alluded to that inside of his slides already. With Embedded Artist, they have a piece to reconfigure the Linux core so that it can support the new display system already. With Storyboard, there comes in a couple of questions. Design is usually done pixel perfect, so if you change the resolution, it's what do you want to do with that change. And by that I mean a lot of people will just scale their application, and that usually doesn't look exactly, because if you just scale a circle by a couple of pixels one way and a couple of pixels the other way, you can end up with jagged edges and not as clean as the designer implemented. So if it was a 2D solution, I would tell them you should go back to design and just get them to give you an updated version with that resolution. If you wanted to change your app inside of Storyboard, it's pretty easy to come into our applications and say, so if we looked at the washing machine one we did, we can come in here and say, resize the Storyboard application. Inside of here, we'll say, which resolution do you want to go to? So maybe I went to a new screen that's 800 by 600. The question becomes, do you want to scale your images or just resize the screen and then I'll do the rest myself? And that's usually what I would recommend is don't scale things because it may not come as you want. So, or I can say custom resize options here, and here we let you say, do you want to update your animations, do you want to resize? We give you a lot of detail here because resizing isn't a one solution fits all. There's a lot of, if you're just stretching the screen, maybe you don't want to stretch anything else. All you really want to do is put like an extra little bar at the bottom. It changes. So the end answer inside of there, Storyboard does enable this. There is a lot of different things to take in, and if you ever want to have a conversation with us about that. The other thing is if you do have a 3D part, OpenGL sometimes can scale it very nicely, but once again, you may want to scale your entire app to fit the perfect resolution on the screen.
All right, the next two questions I believe are related to the importing and what we support. So the first one is, can I import PDF files? If not, what other possible options are there other than Photoshop?
Currently, Photoshop is the main import. You can still pull in your own images and everything. PDF doesn't really break apart the images or give any kind of layering information, so we wouldn't do that. There are other platforms we are looking at for import. Well, we do import FBX files too. So if you're into 3D models, we will not only import the FBX file too, we will import the animations out of the FBX file for your 3D models. But that only matters if you're working on a platform that supports that. We are looking at other options. Some of our designers these days are using Sketch or Illustrator, but some of them don't always map to a pixel-perfect resolution. They're much more vector-based, and they don't really understand the constraints that a screen imposes upon it. So we're always looking at new ones, but if you have options, we can always walk through the best way to move and bring your application if you're using something other than Photoshop.
I think you've answered this at the second question here, but I'll just ask it just so we're clear. What's the difference between working with Photoshop images or simple images made in Paint?
There is no image. There is no difference. A Photoshop file, if you've ever pulled back the layers of the onion, is really just an XML file with inline PNGs. So really what we're doing is we're walking through the file, grabbing all the image data. The effects, the ordering, the hierarchy, the naming, and applying it to the model to save the end engineer's time. What used to happen is the designers would create all this stuff. They would do a dump with all the images, and this is kind of how web development works these days. And then an engineer has to go through and sort of spend a week just putting things in place and making sure everything's in the exact spot they should be. So. Yeah.
Okay, and I think we're hitting the end of our time here, so we'll do one more question, and we'll let everyone know that for the questions that we didn't get to, we'll post them on our blog and send an email with a link to that blog so you can get answers, and we'll try and put some related resources there as well. So the last question is more of an industry-level question, I think, is how often do you see 3D graphics being used in graphical user interfaces?
This really depends on the market and, the application. Some people are using it at So automotive is very big on 3D, especially inside the clusters. But a lot of times people aren't using 3D accelerators for 3D. They're just using 3D accelerators as a way of accelerating 2D graphics. So I would say still the majority of user interfaces are 2D, even though a lot of them are using processors with 3D capabilities, but they're using the GPU to offload the CPU and get the performance that they want even in 2D. But there are still areas where we're seeing a lot more 3D coming. It just hasn't hit the stride yet, except for in areas, as I said, like automotive, some high-end utilities. Some people are just using them for just little effects between transitions, but they're not true 3D UIs everywhere yet.
Excellent. Thanks, Jason. We'll end it there. So I'd like to thank Jason and Anders for our presentations today for Microsoft for an Embedded Artist. And we'd like to thank our audience for attending. For Storyboard, there is a 30-day evaluation at the link shown on your screen now. It's free to download and run, and it is the fully featured version of Storyboard, so you can fully test out all the features, and right from Photoshop import to deploying onto Target and everything in between. We also offer our demo images at the link provided there, so you can download and flash images supporting various boards of different applications on your own systems. And as well, for more information on the Embedded Artists comms discussed today, you can visit the link there. Thanks, everyone, for attending. Have a great day.